Jonathan, welcome. Who is this other person? Floria, right? That is Floria, correct? Right? Is that Floria? What? I have Anna, Floria, and Ruby, correct? Correct? Okay. Without much ado, I will move straight to what we should be doing today. Oh, my laptop has some problems. Okay. Uh, I've just been looking at yesterday's work and I see Bella and Sod, you have not turned in any work. They are not here, unfortunately.
I need to study hard.
Who?
Bella.
Bella needs to study hard?
Yes.
What does that mean?
The art is important for her to attend the university.
Okay, so she's working on art.
Yes.
I thought you meant that she needs to study hard. You mean she's studying art. Okay, I got it. And Sod is not studying math as well because he's being very lazy. I don't know if anyone is in contact with him to let him know. I've given up on Harvey, so no need to think about it. Okay, so let's move on. Did anyone have a problem with what you did yesterday, with yesterday's work? Nobody. Okay. Uh, so for today, we are going to be looking at in what we have done so far, we always know the direction of acceleration. So today we are going to see about if you are not given the direction of acceleration, how do you find it? In other words, how do you find the direction of the resultant force or the net force? Because Newton's second law, F for summation F equal ma, tells us that the resultant force and the acceleration are in the same direction, right? So to find direction of acceleration, all we need to do, my computer is working. All we need to do is find the direction of the resultant force. If we can get the direction of the resultant force, then we know that is the same as the direction of the acceleration. And there are two methods we will use to find the direction of the resultant force. First method, if let's say you have a particle, make it small, and let's say you have a force acting this way. Let's start with the easy case like this. You have another force this way, vertically and horizontally. Let's say this force horizontally is the force P, and this is the force Q. So we want to find the resultant force F. What is F? The same as we used to sum vectors, we can take, we first perform one vector, the force P, and then we take this other vector, Q, it's impossible for me to take Q. And then we take the vector Q, we place it on top of P. From the head of P, we perform Q. So this is P, and that is Q. And your resultant now is going to be from the tail of P to the head of Q. So this is your resultant. And when we say to find the direction, you just need to give this angle theta. From this diagram, we can see that the resultant of P and Q, if P is horizontal and Q is vertical, then the magnitude of F must be equal to the square root of the magnitude of P squared plus the magnitude of Q squared, right? Or magnitude of F squared should be magnitude of P squared plus magnitude of Q squared. In other words, this length squared plus this length squared should be that length squared. And so you can then calculate, find the direction. The direction will just be this angle. You just take this angle. You can find this angle and state it. You can find in any way you want to find, right? Or you can use tan theta is equal to magnitude of Q over magnitude of P. These are not formulas I'm giving you. I'm just, we are looking at the problem, analyzing it with the ideas that are there. Now, you will not always find forces in which one is vertical and another one is horizontal. You may come across a situation in which the forces are like this. Let's say P is like that. And let's say Q is like that. In the same way, this will, you first perform P. And then from the head of P, you perform Q. Q and P. And then your resultant will be from the tail here to the head of Q. This is your resultant force. And if you know this angle, in other words, if you are given the angle between P and Q, This is the angle between P and Q. Let's call this alpha. So this is the angle alpha. And so you can use any way you can use to find the magnitude of F. If you know this angle, and then you know this angle is say theta. So Q, you can use the sine rule. Q over sine theta should be equal to F over sine 180 minus alpha, for instance. Can use the sine rule to find the magnitude of F and the direction theta. But this method is very complicated. It's very complicated and you are more likely to make a mistake. So the best method to use is to use the component method. Component method means you first break the forces into their components. Let's say I have the force P, and we have P can be broken into horizontal X component, call it Px, and a Y component, call it Py. We already know how to break the force P into Px and Py. And then let's say we have the force Q. Also, Q can be broken into Qx and Qy. So you just write these forces in vector form, okay? You can just write the forces. So your P, the force P, is equal to Pxi plus Pyj. Even in three directions, you still get the same thing. I don't like writing vectors in terms of I and j. I like writing this as Px, Py as a column vector form. So this is your P, is this vector. So your Q is this vector, Qx, Qy. If we go back here, you will see that the resultant, you see that this resultant vector F will have a horizontal component, which is just the horizontal component of P plus the horizontal component of Q. And the vertical component will just be the vertical component of P plus the vertical component of Q. In other words, we are just saying that you just add the vectors, you just add them, the forces as vectors, as column vectors. So P plus Q will just be Px plus, maybe I should write it as sum of column vectors, Px, Py plus Qx, Qy. So you simply add these two, right? So you get Px plus Qx, Py plus Qy. And this is very good way to add this up. So this is your F. This is going to be your F. Your resultant force will just be the vector sum of those two forces. Now from here, you'll always be asked to find the magnitude of the resultant force. So magnitude of F will just be the magnitude of this vector, right? So it will be the square root of px plus pqx squared plus py plus qy squared. And the direction. To find the direction, this means you want to find, we will find this angle here. We want to find this angle here. The angle it makes with the x-axis is the best angle to find, huh? So to find the angle it makes with the x-axis, we just have to have tan theta, tan phi. Let's call the angle phi. Tan phi is equal to px plus qx over py plus qy. So you find that is very easy to find, huh? So if you have a question that asks you to find the magnitude and direction of the resultant force, all you need to do is find this and then find this angle, okay? But when you find this angle, you must take that, you must therefore write your conclusion that therefore the resultant force, or therefore F is whatever value you had here. Let's say you had 10 newtons. Say F is 10 newtons at an angle of phi with respect to the positive x-axis, okay? Because it is not always evident that you are finding the angle with respect to the positive x-axis. Sometimes you could find the angle with respect to the p vector. Sometimes you could find the angle with respect to the y-axis, right? So you have to state a conclusion. Let's look at some examples. Exercise 3E. I know some of you are solving these problems very fast and going ahead. Like Floria. Have you solved exercise 3E, Floria? Is Floria there? Floria has turned on her. Floria is in class, but is not there. Ruby?
Yes.
Is that Floria?
No, I'm Ruby.
Have you solved exercise 3E?
No.
Okay, Floria is back. Have you solved exercise 3E, Floria? She's still not responding. She's not there. She's absent from this class. Okay, so 3E, I'll solve a couple of them. The first one says a particle of mass 3 kilograms, M is 3 kilograms, is at rest and has two forces acting on it. So the forces are in equilibrium. One has magnitude 5 newtons and no, the forces cannot be in equilibrium, you know. So it says the particle is first at rest, and then these forces are acting on it, and they act in these directions shown. You are asked to find the magnitude and direction of the acceleration of the resulting motion. Magnitude and direction of the acceleration. So all we need to do here is find the resultant force, right? So your resultant force will be square root of 3 squared plus 5 squared. Of course, if you sketch this force like that, you will see that this is 3 newtons and this is 5 newtons. So your resultant should be like that, which is square root of 3 squared plus 5 squared. And then this is the direction, theta. So the magnitude is square root of 3 squared plus 5 squared. What is that place? That is square root of 34, correct? We'll leave it as square root of 34. And then we know that that force is equal to mass times the magnitude of the acceleration. This means acceleration must be equal to that force over mass. So it's square root of 34 divided by 3. So this is the magnitude of the acceleration, but what about the direction? You've been asked to find the direction. So to find direction, we simply find the angle theta. So theta is tan inverse of 5 over 3. What is tan inverse of 5 over 3? Let me use my calculator. Let me put it in degrees. I like degrees for this problem. So tan inverse, was it 5 over 3? 5 over 3. Get 59 degrees. So it is 59 degrees. So now we can conclude. I didn't find square root of 34 divided by square root of 34 over 3. Let me find it. Square root of 34 divided by 3. That's 1.9 newtons. So it's 1.9. So now I have to conclude that, meters per second squared. I have to conclude that the acceleration is 1.9 meters per second squared at an angle of at 59 degrees to the 3 Newton force, 3 Newton force. Well, since the 3 Newton force is in the horizontal direction, I can say to the horizontal. Okay, this conclusion is important. Okay. Question 3. We are told that a boat has its motor running, creating a force of 500 newtons. The wind is blowing it with a force of 200 newtons. The directions of the forces are shown in this diagram. Find the direction of the subsequent motion. We are asked just to find the direction with no magnitude. But I guess to find the direction, we must find magnitude first. So we sum the forces. Now I will use vector summation. This vector here is just the vector 200, 0. It's in the x-axis, so the y component is 0. This vector here is the vector 500 cos 60 and the 500 sine 60, correct? We can resolve this force into a horizontal component, which is 500 cos 60, and a vertical component, which is 500 sine 60. So your resultant force will be 200 plus 500. What is cosine of 60 anyway? It's a half, right? What is cosine of 60, guys? It's a half. And the 0 plus 500. What is sine of 60? Root 3 over 2, correct? So your resultant force is 200 plus 250 and 250 root 3 or 450 and 250 root 3. And the direction of the resultant force this angle, we need to calculate this angle. So just tan theta will be 250 root 3 divided by 450. And so we can calculate theta, right? So this shows how we can use component method to determine these directions. This should be the last question I will solve today. And I will solve it just like Anna does. Anna does sketches. This force, 35, will have a horizontal component, which is 35 cos 10. It will have a vertical component. Remember, this is in the negative direction of y, so it's negative 35 sine 10. Okay? And then this 20 Newton force will have a component this way, which is 20 cos 60. It will have a vertical component, which is in the positive y-axis. And this is 20 sine 60. So your resultant force, F, will be equal to the sum of the forces in the x direction, which is 35 cos 10 plus 20 cos 60. And in the y direction, you will have 20 sine 60 minus 35 sine 10. You calculate this, and then you find the magnitude, right? Let's calculate that. Let's just calculate 35 cos 10 plus 20 plus 60. Thirty-five cos 10 plus 20 cos 60, correct? So we get 44.47. So this one is 44.47. And the y component, 20 sine 60 minus 35 sine 10. 20 sine 60 minus 35 sine 10. That gives us negative 44.32. So that negative 44.32. And so the magnitude will be the square root of 44.47 squared plus 44.32 squared, right? And the direction so it's always good to make a sketch of your problem. This, what we have here is showing that our force is going to be something like this, 44 and negative 44. So our force is something like this. That is our net force. Okay, so it's always good to have this sketch. And so you have this component and this component. So you need to now calculate this angle, theta. So the angle theta will be tan inverse of 44.4.32 divided by 44.47. And so now you can state that the magnitude of your force, we are looking for magnitude of acceleration. From here, it's of course easy to get the acceleration, F equal ma. So your A will be the magnitude of that force over the mass is 25 kilograms. So whatever you have here will be your magnitude of force, right? And the direction will be tan inverse of that. And then you state that it is in the negative, in the fourth quadrant, or that theta is below the x-axis. Another person could decide, instead of calculating this angle, the person could decide to calculate this angle. It may be easier to calculate this angle for them. You will get the same thing. Whether you state this angle or you state this angle is the same thing, but it is your conclusion that matters, right? So your conclusion will say that the force is this value at an angle of this to the negative y-axis, or at an angle of this below the x-axis. Okay? We still have like 4 minutes left, so I would like to end the class here. If you go in this thing, this one is, if you go on this course, did I add anything here? I actually did not include the class for today. I will include later. Okay, let's end our class here. Thank you, please, for coming. See you.
Bye bye.